For number 3, we have a histogram. We should represent this data properly. So let's label the axis first. What's the x-axis going to be? Time in minutes. The x-axis is time in minutes. What about the y-axis? It's always, for a histogram, it is always frequency density. Okay, remember that. For a histogram, it is always frequency density. So this is our frequency density and this is our time in minutes. Okay, now guys, how are you going to approach this? So we need to find out the frequency density first, and for that we need to apply the continuity correction, right? A normal histogram is a continuous distribution, but there are gaps here, so let's fill that gap up. How do we do this? Upper bound, the lower bound of the next class divided by the upper bound of the previous class divided by 2. That's how you find out the correction. It's going to be 0.5. So this ends up being 0.5 to 30.5, then 30.5 to 45.5, then 45.5 to 65.5, and so on. 65.5 to 75.5, 75.5 to 100.5. Okay, so now let's label these properly. Okay, and let's find out the frequency density. So the class width, what is it gonna be? We need to use the corrected ones. Okay, 30.5 minus 0.5, how much is that? The class width is, class width is 30 for this one, 15 for this, 20, 10, right? And last but not least, 100.5 minus 75.5, that's 25. So let's find out the frequency density. We know that FD is equal to frequency by class width. So 21 by 30, how much is that? 0.70, right? And keep on going. You can show the working for one of them. 21 by 30 is equal to 0.7 FD. Okay, you can show this here. FD is equal to frequency by class width. It's fine. They'll understand. 2, 3.4, 8.6, and 1.8. 1.8 how? 45 divided by 25. 1.8. Okay. Okay, so now let's plot the points properly. How should we do it, right? So they are going to condone if you start drawing the axis from 0. Which means they're going to accept it, but it's typically wrong. It shouldn't be done like that. Okay, so we should start from 0.5. That's the best thing to do. Because why should they condone it? I'm going to tell you why. Suppose if you do start from 0, this being 20 for example, 40, 60, 70, 40, 60, 80 and 100. I'll tell you the issue. So the main issue is you guys know that it's going to be at 100.5, right? And just think about it. If this is 120, this is 110, right? This is 102. Like, how are you going to plot 105 in the 100.5 in the first place? Like, it's too small to plot, right? That's why it shouldn't be done like that. I mean, you could do it, they're going to accept it, but the better way to do it is in such a small number of boxes. The best way to do is this. Let's apply the continuity correction from the first place, right? We can just start from 0.5. So 0.5, this is going to be 20.5, 40.5, 60.5, 80.5, and 100.5. Okay, now this works. So the first one is from 0.5 to 30.5. That means this to the middle region. And what about the frequency density? We need a value till 10, right? Since there's 8.6, so we need a value till 10. So what about this? 2, 4, 6, 8, 10. This looks good. Okay. So 0.5 to 30.5, it is going to be 0.7. So this is 1, 1.2, 1.5, 0.6, 0.7. It's gonna go here. Okay, for the next one, it's 30.5 to 45.5. 30.5 to 45.5, which means here in the middle. Since this is 50.5, it's going to be in the middle. And the value is going to be at 2. The value is at 2. Next, what about the last one? 45.5 to 65.5. Okay, it's going to be at 3.4. This is 3. This is 3.4, right? I mean 3.2, this is 3.4. So it should go up to 3.4. We have 3.4. It will continue till 65.5. Okay, it continues till 65.5. Okay. If you have a scale, you can draw this better, basically. Now, 8.6 till 75.5. 8.6 till 75.5. So this is 70.5. This is 75.5, right? So it's going to be 8.6, 8.2, 4, 6. It's going to go up like this. It's 8, 8.4, 8.6. Okay. So this will continue till 75.5, this point over here. Okay, kind of like this. What about the last one? It's going to go till 100.5 and it's going to be at 1.8. 1.8, okay? So 1.8 is over here. 1.8 till 100.5. Okay, this works. One other one was also accepted. You could start the axis from 0, that's fine. But then you'd have to slightly displace your graph. Do you get what I mean? You'd have to start from here instead. And you had to end the graph a bit later. Like if this was 100, you needed to end the graph here at 100.5, okay? That's another way you can do it. So which class interval contains the median? How do we do this? There are 250 children in total. So for an even number, what's the rule to find out the median? It's going to be 250 divided by 2 plus 250 by 2 plus 1, right? So 250 by 2. That means the 125th value and the 126th value, the average of those two values. So basically we're looking for the 125th value and the 6th one. So if we add these frequencies to get cumulative frequency, think about it. In the first class, it's just 21. 21 plus 30 is 51, plus 68 is 119. So till this class, we're getting 119. So the median is not in this class. If you add 86 to it, you're getting 205. So the median lies within the class 66 to 75. Clear? Now, given that an estimate of the mean is 61.05, state what feature of the distribution accounts for the median and mean being different. Okay, so the mean is something like 61.05 while the median is somewhere around 66 to 75. What does this mean? When is the mean and median the same? Think about it. If it's a perfect normal distribution, think about it. the value is at 0, 0. The mean is 0, the median is also 0 for a perfect normal distribution, the standard one. That means the data is not skewed or it's symmetrical. If the data is skewed, slightly positively or negatively skewed, then the mean and medians are different. Okay, very important theory. The distribution is not symmetrical. Okay, and you can easily see this from this diagram. Think about it. What's happening? It is not centered around the middle or the mean. Okay, it is slightly positively skewed towards the right.